Hello grade 12s. Today we will look at how data can be represented. We will look at line graphs, different types of bar graphs, and histograms. Summarizing data using averages or measures of central tendency give us the idea about the data. However, graphs provide us with a visual representation of the data which may appeal to a lot of people. To start us off, let's join Lebo and her teacher as they use a line graph to track the price of the drinks Lebo buys. Lebo has kept track of the price she's paid for the drinks over a period of 3 months in this table. Let's join them now.
Let's see how we can use this table of data to draw a line graph. Here is a sheet of graph paper. The first step is to decide in which direction to draw in the axes and what to label them. Have you got any ideas?
Well, I could put the price of each drink on one of the axes and the date on the other of the axes. Because I have 10 entries, it would be better if I turned the graph paper around so that the horizontal would be on the longer and the vertical line would be short.
That's a good start. You can draw in the axis lines using a ruler and pencil. Remember to put an arrow on the end of the lines to show that these axes continue. Be very careful about how you represent time on the horizontal axis. Although there are only 10 dates, the time period is 90 days. Because February had 29 days this year, March had 31 days, and April had 30 days. To show time accurately, we need to choose the right scale for the graph and spread these readings out to show the true reflection of how prices have changed over time. Do you have any suggestion of what scale to use?
I've counted the blocks on the graph paper, and there are 10 small blocks inside each big block, and there are 14 big blocks on the horizontal line. So each big block can represent 10 days.
Yes. However, we don't want to label this axis using number of days, but dates. Write the date underneath each of the thick lines and use your pen to label the axis.
Okay, so the first date I mark on the axis is the 10th of February, then the 20th of February, then the 1st of March, and so on till I get to the 30th of April.
Good work. Next, write in the axis title on the horizontal axis before moving on to the vertical axis.
Okay, I'll write dates below the axis.
What about the vertical axis?
That's probably a lot easier. As I look at the table, I see that the lowest price is R3.75 and the highest price is R8. So each large block will represent R1 starting from 0. So they should all fit in. I'll label this axis the price of cold drink in rands.
Before you start plotting your points on the graph paper, add a heading for the graph at the top of the page.
Okay, next I'll match the prices with the dates I bought the drinks.
It's usually best to plot your points using a pencil first so that you can make changes if there's a mistake.
I bought a cold drink on the 4th of February for R4.50. Now the 4th of February is the 4th narrow line. I will match this date with R4.50, which is halfway between 4 and 5 rand, and I'll put my mark there.
Excellent. If you repeat these steps, you'll soon complete plotting all your points. It gets a little tricky if the points are far from the axis. I sometimes use a ruler to mark off the position of the point.
Thanks. Using a ruler is helpful in plotting the points easily. What do I do next? All I've got in the graph are 10 points scattered across the page. How does this help me?
There is already a lot of information you can get from just looking at the data. Although the points are scattered, there is a general pattern. The points group together for a certain time and change and then group again together at a higher position. Without even drawing a line, I can see that the price of cold drink has increased over time. You could plot all the prices of items you bought over this period onto one system of axes.
What else can I do with this graph?
If you join all the points you plotted in a straight line, you'll be able to see when prices changed and when they stayed the same. When the line between 2 points is flat, there is no increase in price, but when there is a steep line going, it represents an increase in price. The steepest line between 2 points shows the biggest increase.
What does this line mean?
That downward slope shows a sharp decrease. Remember, you paid 8 Rand for a cold drink at Athletics and you tried a cheaper brand the next time.
Oh, of course I remember. The prices were so expensive, I felt badly ripped off.
The decision to use a line graph was motivated by the desire to see the trend in the price of the drinks label bought. Line graphs are very good at showing the general direction in which a set of data is developing or changing. It is useful to represent temperature changes, exchange rates, and term marks of a subject. This is a multiple line graph and shows the maximum and minimum temperatures. Such a line graph could be used by tourists for holiday planning purposes. All graphs, whether they're line graphs, bar graphs, or histograms, need to be labeled correctly. Remember that when you plot a graph, you must give your graph a title and label the 2 axes. Bar graphs are very useful for representing categorical or discrete data. Remember that categorical data includes data like car colors and types of food. Discrete data assumes limited values like whole numbers. Examples of discrete data include number of students in class and number of cars. Let us consider the summary of grade subject choices for 2 schools, Amber High School and Parks High School. There are 2 sets of data in the table, the subject choices of Amber High School and Parks High School. To represent all of this on a bar graph, we will need to use a compound bar graph. This compound bar graph compares the number of learners who choose certain subjects in the different schools. It's quite easy to see that more learners in Park High School chose maths literacy. But what if we want to see the total number of learners who received marks between 80 and 100%? Let's look at another type of bar graph which shows this. This stacked bar graph makes it very easy to see that the majority of the learners received between 80 and 100% for maths literacy. It is very useful in showing grouping in data. Histograms are used to show continuous data. Continuous data is data that can be any value. Fractions, decimals, whole numbers, and examples include data like mass and height. The bars of a histogram have no gaps between them because our data is continuous in nature. Let's look at a table of masses for a class of students at Amber High School. There are 35 learners in the class who have each been weighed. The table shows that there were 3 learners with masses greater than 40 and less than 50, 8 greater than 50 and less than 60 kilograms, 15 greater than 60 but less than 70 kilograms, 7 with greater than 70 but less than 80 kilograms, and 2 greater than 80 but less than 90 kilograms. Let's look at a histogram that represents this data. We label the vertical axis frequency and the horizontal axis as mass in kilograms. The bars are equal in width without gaps between them. The height of the bars is determined by the frequencies. The histogram shows us the shape of the distribution of our data. The original data was grouped and therefore we cannot have a single value to represent our mode. So we end with the modal class. We can see from the graph that the modal class is greater than or equal to 60 but less than 70. This means that most of the learners in this class have masses greater than or equal to 60 kilograms but less than 70 kilograms. Thank you for joining us, grade 12s. And remember to look at the advanced data handling task video. You'll also learn more about data handling on our website www.mindset.co.za/learn. Goodbye.